Hello everyone, Anthony here, your favorite coding superstar, once again with episode 12 of creating a production-ready blockchain from scratch in Golang. And before we going to continue where we left off, I'm gonna reveal, or I wanna discuss real quick what I wanna do with this chain, because we are making this let's say this prototypish modular blockchain thing and without any purpose. And I have two very nice ideas and you guys can decide what it's going to be. I'm going to set up some kind of a voting mechanism. I don't know how I'm going to do it, but you guys can vote it. And the first thing that I had in mind is, instead of making it some kind of a general purpose blockchain like Ethereum or Solana, why don't we make it a decentralized order book that can be used for decentralized exchanges? Because right now a lot of those exchanges are basically I don't think they are very decentralized unless you have those protocols like Uniswap and those other things, similar protocols that are built on Ethereum, which are very slow and most of the time expensive. Why don't we make it why don't we make the blockchain understand exactly how an order book looks, so we can create a decentralized exchange without any single centralized authority? That would be amazing. I know there are some projects that are trying to do this. I'm not sure if they are already on the market, no idea, but that would be nice. The second idea is basically, let me open up what I mentioned by this. I don't know if you guys know what the Move language is, but the Move language is basically, I think it's created by Facebook back in the days for their Libra blockchain. It's a way to write smart contracts. It's like Solidity. It's a competitor of Solidity and Viper and all those other languages. And it basically looks like Rust. And it's specially designed for creating smart contracts. Because let us be honest, Solidity is old school. It has its time. It's basically, I don't like the language. It's not safe. So many issues, and Move is trying to solve a lot of issues that Solidity has. And it would be nice if we could create a general purpose chain with a Move virtual machine inside of it. That would be insane. But I did a little bit of research, and Move is written in Rust. And there are no libraries in Go. There is no bindings. There is nothing. It's basically, the documentation is okay for the language itself, for the syntax, but the documentation for basically using this in another project is non-existent in my as far as I know. So if somebody can find some more useful information for this, please let me know. But guys, can you imagine that we create a general purpose blockchain with a Move virtual machine inside it, so people can write smart contracts in Move, deploy them on the blockchain, on our blockchain, and call it a day? That would be so amazing. Can you imagine like those giant teams raising thousands and hundred thousands of dollars, hiring 15 people to create some blockchain that actually is never gonna be released, and we are going to make one single-handedly, where we record byte by byte how we do this and put it open in the world? Can you imagine? We're gonna write history. So yeah, that are basically the two ideas I had in mind. Or we make it a general purpose blockchain with a Move virtual machine, or we make it a decentralized order book that can be used for trading NFTs and asset and shitcoins and whatever you want to trade. That would also something very exciting. So that was that. Yeah, let's get back to the task at hand today, and that's basically going back to server and check what we did. So Create new block. So that's what we did yesterday. Well, for me it's yesterday. Not quite sure what day it was for you when you watched this video. It could be 1 hour ago. I don't know. You tell me. Create new block. So let's just to make a run here real quick and drink coffee. So yeah, we are creating blocks, and let me quickly here of my computer is making incredible sound. And I hope you guys don't hear this steam that's coming out of the computer. Anyway, create new block. So we're creating new blocks, but new block from pref header, we are not including transactions yet. So what we're gonna say is basically txx, which is as mempool, as mempool transactions like this. It's not like this. It's like this. And then we're gonna include all these transactions. Normally, what's this? Yeah. Okay, it wants pointers and it doesn't get one. So let's open up block. Man, I need to, it's early in the morning. I literally just awake and my brain is still sleeping. New block from pref header. It wants this list of transactions and we're gonna give it pointers. Like this, and let's fix it here also. And then we're just gonna say we want transactions, which is more memory efficient. Let's test this real quick. Block 65. Okay. New block. Test. Block test. And this one. Oh yeah. We want pointers. Random text with signature, and I think then we are good to go. Transaction test. We want a pointer, so basically we say it's going to be this, and this should work. Okay. All right, fixed it. So now, server, we could do yeah. So let's first basically clear this a little bit out. So for now, Later on, when we know the internal structure of our transaction, yeah, we will implement some kind of complexity function to determine how many transactions can be included in a block. So for now, we are going to use all transactions that are in the mempool. Later on, when we know the internal structure of our transaction, we will implement some kind of complexity function to determine how many transactions can be included in the block. Okay, so normally we cannot include all transactions in a block, especially not if we have a lot. So we need to have some kind of a function, like I mentioned previous episode, that will determine how many we can include based on, like Bitcoin, based on size or based on some kind of a complexity of the internal script that will be executed by our VM if we are going to do this. And then we will implement that. So for now, we're just going to say include everything and make it good. So yeah, fetch all transactions from the mempool, put it in the block, sign it, add the block. And if we have no errors, so basically if this all succeeds, we're going to say as mempool flush. Yeah. Yeah. Flush the mempool and then return nil. No error. Okay, cool. So that should normally work. Let's test this. So we are making all these transactions. Okay, we have a block and then we reset the mempool. Yes, perfect. Perfect. Okay, something we want to do real quick is, let's open a blockchain. We're gonna add a logger, which is a logpoint. So logger is gonna be, I don't know what it is, but each time in VS Code, when you're in this thing, it's so laggy, you have no idea. You have no idea actually. Like this, and then we're gonna say BC loggers log message adding new block. New block. Wait, let's make it clean from the beginning, to be honest. And then hash of the block. Default hash. Block hashes. Default height. And let's say transactions. Something like this, and then we can remove this logger's garbage like this. Yeah. Make run and see what's happening. Okay, I did it. Oh yeah. Oh. So we have a logger and it's trying to log, but we don't. It's nil. So basically, we're gonna say logger, and then logger is gonna be L like this, and open up servers. Damn, this computer is it's insane. It sounds like an airplane that's It sounds like an airplane that's going to lift off. I'm not gonna lie. And I have my headset on and it has noise cancelling. So I hope you guys are okay on the other side of this. Okay. Corporate new blockchain. So we need a logger and we're gonna say it's open logger and call it a day. Okay. So we're adding this transaction to the mempool and then we're creating a block and we say 5 transactions. Yeah. This is cool. This is cool. I like it. Cool. It's working. It's working. Yeah, but now we're going to do something very nice, and that's basically we are going to add multiple nodes and we are going to distribute that block. Yeah, the mempool, I was thinking about the mempool and there are some issues with it, but I don't think we're gonna solve it today. I really want to, by the way, but I need to stick to the plan. It's so important to stick to the plan. And the reason is, I will explain later on. You will see. Holy shit, what's this? I will explain what's going on. So basically, let's go to main. So what's happening in main? We have a local and a remote transport, but we only have a local server. And this is this nasty send transaction function. Okay, what we're gonna do is we're gonna say make server with a transport network transport and to turn a network server. I'm gonna make some helper function. This is all basically, this whole main file is prototyping. This whole main file is experimentation. It's nothing that's gonna be committed to production or that's gonna stick in the code. Server. So what I'm trying to set things up so we can create multiple servers and actually do some nice stuff. So then we're gonna say it's gonna be network new server, I guess, with the ops. What the hell's going on? Just a second, guys. Oh. Too bad. My gym partner cannot train today. But that won't stop us. That won't stop us going hard once again, like every day. Okay. So we have make server. That's nice. So what we're gonna do is we have transport local, then we have transport remote A, and I'm gonna make B, C. So we have 1 local transport, 3 remote transports. And let's give them B. Actually, yeah, doesn't matter. C. So now we're gonna say we are not gonna connect them all to each other. We're going to utilize the network's gossip. The network gossip shenanigans to distribute transactions and blocks. So we are gonna say tr local connect with tr remote A, for example, and then we're gonna say tr remote A connect with B, and then B is gonna connect with C. Okay. Wait, this we're gonna quickly do this. Delete these options. We have this private key, and we are gonna say our server, local server, is gonna be make server with local ID. The local transport, and we're gonna give it a priv key. So we're gonna have one validator for now, one validator. Local server start, priv key, what the hell's going on? This should be a pointer. So we make our local server, and now we're gonna say make remote servers or something. TRS is gonna be network and transport, like this, or say okay, make server. I'm just trying to, it's very early in the morning, I'm so sorry. So make server, oh man, fmt s print f, I guess, remote is going to be y, and then we say this is the ID, TRS Y, and we don't want a private key. Fine. And then we say go as start. Oh wait, we can actually. Yeah. We need to do this in a separate Go routine, because otherwise it will block. Okay. Okay. So we're gonna say init remote servers, and we're gonna network.transport, and it's gonna be tr remote A, tr remote C, and tr remote B, D, B. What the hell am I doing? It's B, A, B, and C. Okay, cool. That's what's gonna happen. Okay, let's quickly check if this kind of works. Make a run. Okay, yeah, it's fine. Cool. There are no transactions because we're not sending one. We are making blocks with 0 transactions. That's fine, and only our local is doing it. And then you can see remote 1, 2, 1, basically 0, 1, and 2 are creating new blocks, but that's the Genesis block, and I hope it's the same hash, and it isn't. Look at this. Yeah, that's an issue actually. We didn't think about that. So the Genesis block for now is basically just a placeholder. Let's open up server, and let's check this Genesis block. This is the problem. It's the timestamp, right? I mean, yeah. Does it matter? It doesn't matter at all. No, so basically a Genesis block should have like a predefined thing and one timestamp, and it's one thing. And we just did a random time. It doesn't make sense. It doesn't make any difference for now because A Genesis block is for now just a placeholder. We don't know what it's gonna be yet, so we are just mocking things out, putting things in place. Okay, so what the fuck is this? Mag. Okay, cool. Next thing we need to do is go back to main, I guess. Is it? Yeah, this thing. So somebody is going to send transactions. What I also want to do is create some kind of a client that sends transactions to the API of our nodes, but we don't have an API yet. So we are going to use some kind of a other node that sends transactions to our local or something, and then our local broadcast this to anything else. But we need to... Okay, so local is connected with A. A is connected with B, and B is connected with C. So let's say tier remote A is going to send to to tier remote to tier local. Yeah. Okay, so remote A is going to send transactions to our local node, and maybe we should do something like 2 seconds or something to make see what happens here. Could not send to message local. Yeah, and nobody gets the transaction. That's because we couldn't distribute this. Remote A could not send message to local with this. RPC. No, it's not RPC. Local. Local transport. Could not send message. Oh, the peer is not in its map. I see. Could not send a message. I'm thinking for a better. Could not send message. Peer. Not on map. I don't know. Oh, I know something much better. Unknown peer. Yeah. Main. So that's basically because TRA is sending to tier B, but TRA is not connected to tier B. What the hell? I mean, TRA is sending to local, but TRA is not connected to local, it's only connected to B. So what we're gonna say is tier remote A connect to local. Yeah. So now you can see that basically every remote is getting the transaction, although only A is sending to. Man, this is getting so confused. Not gonna lie. Only remote A is sending to our local nodes, but also B and C are getting the transaction, as you can see. So that's perfectly fine. And you can see that our local node is creating blocks. And, oh, damn it, what the hell is going on? I'm so sorry. But I also need to work sometimes, and if people need me, I need to respond. But, so it's clearing its mempool. The problem is all the other remotes are not clearing the mempool because they are not creating blocks. And they are also not adding blocks because we are not distributing the blocks. We are not broadcasting the blocks just like we did with transactions. So that's what we are going to fix. Yeah, server. Okay, cool. So what needs to be done? As you can see, we have something that is called broadcast process broadcast TX. So we need to have something like broadcast block, okay, which is going to be core.block block error. And we're going to return nil because, as you can see, we need to have block punt and code. I think we have that, to be honest. Buff. Not sure what it is today, but I'm not 100% focused. Okay, that's no. We need to have some kind of a block encoder, and we don't have it. So we need to do just return null and open up block. See what's going on. We need to have a block decoder, and we don't have it. So open up encoding. Yeah. Okay, how are we going to do this? It's 30 minutes. Maybe we split this up because this is gonna take some time. I need to be super smart about this. Yeah, so maybe let's just recap, right? Because if I need to do it right now, this video is going to be too long, and people don't like long videos, and yeah, you know what it is. So for the next episode, we are going to make this block encoder, so we can actually send broadcast blocks over the transport layer to our other nodes. And then we actually have some kind of a network that is working. Although there are some issues because, yeah, I won't front run. Very important is, remember what I told you guys in the first part of the episode. What are we going to do with this chain? Are we going to make it a general purpose chain with the move virtual machine, which is it's a very nice project. I'm not gonna lie. It could bring a lot of value to the community, because there are not many blockchains that use general purpose blockchains that actually use the move virtual machine yet. So that's that. And the other one is basically create a decentralized order book for making decentralized exchanges, which is also nice. Up to you. Let me know if you like this video. Please give me a thumbs up. Put your questions, remarks, whatever, critic into the comments, and don't forget to subscribe to the channel. Oh my goodness, it's so early. Don't forget to subscribe to the channel. Thanks for watching, and see you in the next one. Bye bye.